The next about 2 hours presentation will be focused on post-tension concrete, the construction and observation issues. Now, a lot of you, if you don't have a working knowledge of the design of post-tension concrete, that's not going to be a negative for this webinar. There are a lot of photographs, a lot of discussions on how it should look and what to look out for if you're doing the observations that really have nothing to do with, stress checks or ultimate strength and stuff like that. So even if you're a little light on the PT numerics, I think you'll still get a lot of valuable information from just understanding what it should look like and the things to look out for when doing an observation. Now, what we're going to talk about today are a number of items that I find as the critical kind of issues that I see during observations. One is a tendon layout, curving of tendons both vertically and laterally, anchorage zones, which are really critical in podium slabs and also in mat foundations. There's a lot of discussion on pour and delay strip, not so much in the use of them, but also in the construction. That we have I would say, the biggest issues, not so much in the numerics of it, but how the contractors actually build and form and shore the delay strips. Slip connections are very important to preserve the aesthetics and minimize cracking as much as possible. And a lot of times it's not for the cracking of the slab, it's more the cracking of the non-structural walls, your CMU shaft walls, elevator shafts, and stuff like that. Conduit is always a problem. Everyone loves electricity as much as the next person, but plowing it through your decks can cause a lot of grief and cause a lot of issues. And so there's a lot of things to look out for. And there's also a code approved way to do it, which you'd really push to the contractors. Penetrations obviously are always an issue. Integrity tendons, which is a code requirement, we'll go through those. And then lastly, elongations, what they actually mean to us as engineers, what to look for, and what to do and what not to do if you actually have an elongation issue. So before I get started, as Maria mentioned, my business partner and I, Dirk, wrote a book, Post-Tension Concrete Principles and Practice. We're in our 3rd edition right now. And the book basically covers 2 major topics. One, the first 9 or 10 chapters is the undergraduate course. So if you have never took an undergraduate PT course and have very little, knowledge of it numerically, this will pretty much teach you exactly what you need to know from an undergraduate course. It's currently being used, the book itself, at UCLA, Cal Poly SLO, Cal State LA, and the University of Portland to teach their undergraduate class in PT. The last half of the book, the last 9 or 10 chapters, is all construction design examples based upon what basically we do every day of our lives in the office. There's examples for two-way slabs, podium slabs, mat foundations, diaphragm design, slabs on ground for residential construction. There's a whole chapter on construction and observations, which basically is what this webinar is about. So if this seminar is something that you're interested in and want to pursue further, the book has a number of different topics that deal directly with post-tension concrete. And you can purchase it through SK Goshen Associates on the same website that you signed up for this seminar. So first of all, we're going to look at, this is a typical two-way slab layout for a parking structure that's currently in construction. And this photograph is what it should look like. Now, a parking structure is very similar to hotels and also for office buildings. So it's a very simple layout. There's not a lot of embedded items. There's not a lot of openings and stuff like that you would see in a podium structure or something like a park. But the nice thing about this layout is the uniform tendons should be at a relatively equal spacing. Now, in terms of doing an observation, and I do a lot of observations for these type of slabs, I do not use a tape measure to measure CGSs, which is the location of the strands. I defer that totally to the inspector. That's not our job as a structural observer. Basically, from this point of view, I like just to look at the cross section of the slab and look for whoopses or extreme bends, extreme curves, something that just really looks out of place. The tendons, if done correctly, should always look a gradual profile, nothing severe, nothing out of the ordinary. And basically, if you can look for those items, that's the big ticket item. You want to see things that are smooth and gradual and basically looks very, very vanilla in these type of situations. Now, as a structural engineer, what we do primarily is give the location of the high point, which is right here over the support, and then the midspan point here, and the midspan point there. So if you really do want to check the CGSs, you would check it at those locations.